Hello and welcome back to the beach. Today what we're looking at is high-low cost estimation method, and it's part 2, which looks at stepped fixed costs. Now I'm going to make the assumption that you've already looked at high-low cost estimation method part 1, so you have a basic understanding of what's going on here with regard to things such as our cost behavior. And what we have is past actual relationships that we're going to establish. So we've got past actual results in terms of how much it's cost us to do something, which is my $sign over here, and then how much we've produced in terms of quantity, which is my Q down here. So you understand precisely how the X and the Y axis work. Once we've got that, we're now going to take it to the next level, and we're going to start looking at some nastier examples. Now, what we did on the first part of these 3 exercises, the first part of these 3 recordings, was we had a look at the idea of trying to find fixed cost and variable cost per unit based on just joining these 2 points together, putting a straight line relationship in there, and try to identify the gradient of the line to be my variable cost, and then where this line goes through my y-axis all the way over here on the left-hand side, that's where, just there, that's where I'm going to find what my fixed costs are going to be. So that's the fixed cost element, and then my variable cost will be the gradient here. And what we're going to do here now is we're going to add in some other funkiness. What we're going to do is we're going to add in a step to the fixed costs. So instead of having this lovely straight line, there's going to be another step in the straight line as well. And to show you how this is going to work, what we're going to do is we're going to make up 2 examples. We've got our oranges example and then our apples example. And we're going to start off with oranges. And what we're going to say here is this. If you have a situation whereby oranges will cost you $4 each, and if you want to put them in a crate, the crate will cost you $100, and each crate can hold on to 50 oranges. So each orange costs you $4. You can put 50 oranges into a crate, and it's going to cost you $100 to have the crate. If you've now got a crate with 60 oranges in it, that now means you've got 60 lots of $4, which would be my variable cost. You've then got 2 lots of fixed costs, because we're going to treat the crate as though it's a fixed cost. So you get 2 lots of $100 plus 60 lots of $4 gives me a total of $440. If you had a situation whereby we only had 15 oranges, then my total cost comes in as 1 lot of fixed costs plus 15 oranges at $4 each gives me a total overall of $160. Okay, Ed, I get where you're going with this. There's the numbers. So the first one with 60 oranges has got 2 crates, 2 fixed costs. The second one with 15 oranges has got 1 crate, 1 lot of fixed costs. There's the issue. We're still going to be using our algebra, which is y equals a plus bx. And this is what all of our different variables mean. You should remember this from the first example. So y is my total cost, x is the number of oranges, a is my fixed cost, and b is my variable cost. Now what's going to happen is we're going to have 2 different equations. So we've got the situation with regard to 60 oranges. And remember, 60 oranges involves 2 crates. So 60 oranges, which cost me $440, equals 2 lots of fixed costs plus 60 lots of variable costs. So plus 60 lots of variable costs. So there's the interesting aspect there. Then what happens is when we've got our 15 oranges, for 15 oranges it cost me $160. That's 160 equals 1 lot of fixed costs plus 15 variable costs. So there's the big difference. We've got now multiple A's as well as multiple B's. And what we need to do is solve the equation to try and find out what A and B is going to be. So we need to try and solve the equation to work out what A and B can be. That's the issue we've got. There's the problem we have. Now to do this, what I'm going to do is I'm going to take that 440 equals 2A plus 60B, and that is going to become my high equation. The 160 equals A plus 15B for 15 oranges. That becomes my low equation. But I need to change these such that they work for the same number of fixed costs. So we have the high equation and then the low equation. What I'm going to do is I'm going to take the low equation and double it up so that we can completely eliminate all of our A's. So if I double up the low equation, that now gives me 320 is 2A plus 30B. So that's my new version of the low equation. What I can now do is I can subtract the high equation and then take away the low equation. So that will now give me 440 minus the 320, which is going to be a total of 120, equals 2a minus the other 2a means that the 2a's cancel out. I have 60b minus 30b, which gives me a total of 30b, which means that my variable cost B comes in at 4, which is exactly what we think it should have come in at. So that's precisely the number that we were looking for. Okay, if I then take my B equals 4 and I substitute it back into one of these two equations, and we'll take the original low equation where 160 equals A plus 15B, that now means that 160 equals A plus 15B. We now know that B equals 4, which means we can work out that A, my fixed cost per crate, is going to come in at $100. So that now means that A, my fixed cost per crate, comes in at $100. Now, just to make sure you're completely comfortable with this, we have an additional example, which is going to be my apples example. And with the apples example, what we have is total costs are made up of a variable cost per unit and a fixed cost. There is an increase in fixed cost of $40 for amounts in excess of 30 apples. So maybe we need to buy another machine. And the actual results that we've got in the previous periods are for 35 apples and then also for 5 apples. Now be careful here, guys, because when it says 35 apples, that means it's in excess of 30. So that's where we get our step in the fixed costs. So that's where we're going to get our step in the fixed cost. So I need to take that into account. Now, when I'm looking at that type of step in the fixed cost, it's going to be an extra $40 for amounts in excess of 30 apples. This now means that my equations will become $345 equals my fixed costs plus the extra step of $40 plus 35 variable costs because there's 35 apples. My low equation is going to be 95 equals fixed costs of A plus 5 lots of apples, so 5B. And what I can now do is I can substitute or subtract these numbers through. So the low equation gets subtracted away from the high equation. That gives me 345 minus 95, gives me 40 plus 35 minus 5 gives me 30B, which means that in total, once we take the 40 to the other side, we now end up with $210 equals 30B. So B is going to equal $7 per unit. If I then substitute that back into my equation, I then get a figure which says that my original fixed cost will be $60. So my original fixed cost will be $60. And I can now work out what my enhanced fixed cost will be because I know it's going to be an extra $40 on top of it. Now, hopefully that all makes sense. Do make sure you go through those examples again to make sure you're completely comfortable with everything we've looked at there. We do have a third part to this which looks at reducing variable costs, which is the other curveball you may potentially see in this type of situation. Thank you very much for your time and attention. I'll see you all bright-eyed and bushy-tailed on part 3 very soon.